Hi there and welcome to another FlipChem video. This time we're going to go through a past paper question on the period-free elements and oxides. The question details and formatted on the screen now. Let's get started. Here's the first part of the question. This question is about some period-free elements and their oxides. Write an equation for the reaction of phosphorus with an excess of oxygen. I recommend that you learn the reactions of the period-free elements and oxides off by heart. Phosphorus catches fire in air, reacting spontaneously with the oxygen present. Phosphorus oxide is P4O10. Here's the balanced equation. The other period-free oxides are Na2O, MgO, Al2O3, SiO2. Sulfur makes two common oxides, SO2 and SO3. Here's the next part of the question. Describe a test you could carry out in a test tube to distinguish between sodium oxide and the product of the reaction in question 6.1. Sodium oxide reacts with water to produce sodium hydroxide. Phosphorus oxide, P4O10, reacts with water to produce phosphoric acid. We can tell the oxides apart by adding water and testing with universal indicator. The basic solution formed with Na2O will turn universal indicator blue. The acidic solution formed with P4O10 will turn universal indicator red. Here's the next part of the question. State the type of crystal structure shown in silicon dioxide and in sulfur trioxide. Silicon dioxide has a giant structure with covalent bonds between the atoms. This is one of the few giant covalent structures, along with graphite and diamond. SO2 has a simple structure. There are covalent bonds between the atoms in each molecule and weak intermolecular forces between the molecules. Here's the next part of the question. Explain why silicon dioxide has a higher melting point than sulfur trioxide. Melting point explanations are always linked to structure and bonding. We have to relate the melting point to the energy required to break chemical bonds if the structure is giant, or intermolecular forces if the structure is simple. When silicon dioxide melts, strong covalent bonds between atoms are broken. When sulfur trioxide melts, weak intermolecular forces are overcome. Covalent bonds are stronger than weak intermolecular forces. Much more energy is needed to break the covalent bonds than the intermolecular forces. Here's the next part of the question. Write an equation for the reaction of sulfur trioxide with potassium hydroxide solution. Sulfur trioxide will form sulfuric acid with water. We can think of the reaction of sulfur trioxide with potassium hydroxide as an acid plus alkali reaction. Sulfuric acid will make sulfate salts, and so the equation is SO3 plus KOH goes to K2SO4 plus H2O. Finally, we have to make sure that the equation is balanced. Here's the next part of the question. Write an equation for the reaction of an excess of magnesium oxide with phosphoric acid. Metal oxides are bases. You also need to know the formula for phosphoric acid, H3PO4. An acid, when it reacts with a base, will give salt plus water. The formula of the salt can be deduced by ensuring that the charge of the anions and cations cancel. Magnesium is in group 2, so it forms 2 plus cations. The phosphate ion is PO4 3-. Finally, we have to ensure that the equation is balanced. Here's the final part of the question. Draw the displayed formula of the undissociated acid formed when sulfur dioxide reacts with water. When sulfur dioxide reacts with water, sulfurous acid is formed, H2SO3. It is worthwhile knowing the structure. If you aren't sure and this type of question comes up in an exam, you may be able to deduce the structure by applying your knowledge that oxygen usually makes 2 bonds and hydrogen usually makes 1 bond. Thanks for taking the time to watch this video. Questions and comments are always welcome. Take care and goodbye.